All right, so we've looked at measures of the center. Now we're going to look at measures of spread or measures of variation. So our measures of spread, we have three that we're going to look at. We have our range, our standard deviation, and our quartiles. And our quartiles will be in the next section. So the range of a data set is the difference between the highest and the lowest data values, or maximum and minimum values. And so my range, there is a formula for it. This is the fastest way to figure out the spread of the data. Usually it's not the most accurate. We tend to use standard deviation, but it is a quick look at sort of what's happening with the data. So for example 1, we want to find the range. So we want to look and try to find what the lowest value is. And it looks like it's 14. Oops, I thought that was on highlighter. Let's try that. So 14, and then what the highest value is, right? So I'm going to say it looks like it's 68, right? So those are my highest and lowest. So we would take my range would be the 68 minus the 14, right? So my 68 minus 14, or 54. So range would be 54 in this case. Now again, the most frequently used measure to describe the spread in a data set is the standard deviation. So my standard deviation, it measures how far on average each observation lies from the mean. The average distance of each observation from the mean. So note, the standard deviation is not a resistant measure of spread, meaning it is inflated if there are potential outliers. The sample standard deviation is denoted by S. So some standard deviation facts. My standard deviation is always 0 or positive. A small standard deviation means that the data values are closely clustered around the mean, and a large standard deviation means that the data values are more spread out from the mean. So let's take a look. Let's recall from chapter 1, right? It says a blank is a descriptive measure for a population. And so it's a parameter. A parameter, right, describes a population. And if you remember, a statistic is a descriptive measure for a sample. Sorry, it should say statistic. Our variables as variables as they change depending on the particular sample that is obtained from the population. So my following summarizes the difference in both the formulas in notation for parameters and statistics. So I have my sample, so we have a sample variance, which is squared. We tend not to use our variance only because when we look at the unit would be squared, and sometimes it's really sort of meaningless to be able to do that. So the standard deviation tends to be the one we use because the unit matches the unit in our data set. So but my sample variance is S squared, and then it's the sum of X minus X bar quantity squared over N minus 1, where again, X bar is the sample mean, N is the sample size, and the sigma means to find the sum. The sample standard deviation is just the square root of that. And just note that the N minus 1 on the bottom has to do with a concept called degrees of freedom. Basically, it makes the sample standard deviation a better approximation of the population standard deviation. My population variance formula and my population standard deviation almost look exactly the same, right? The structure is the same for a sample based on a sample. But the population has different letters, right? So it has mu and it has N, where, right, mu is the population mean, N is the size of the population, and we represent variance by sigma squared. My population standard deviation is just the square root of that. So we will go through and we'll walk through how to do one by hand. And then I will show you how to do this in the calculator. Definitely faster in the calculator, definitely usually the route we want to go. But it is important to sort of know and understand where we're sort of calculating this by hand and how each of these variables sort of come into play.